Welcome back students. In this video we will discuss about the Bernoulli distribution and I will tell you कि किस केस में Bernoulli distribution ही आपका binomial distribution बनता है. Okay. And in this Bernoulli distribution your random variable x will take only two values, either 0 or 1. तो from here you can easily say कि या तो probability success की निकाली जाएगी या फिर probability फेलियर की निकाली जाएगी, बीच में कुछ नहीं होगा. ओके तो व्हाट इज बर्नौली डिस्ट्रीब्यूशन, विच टाइप ऑफ रैंडम वेरिएबल फॉलोज बर्नौली डिस्ट्रीब्यूशन. अ रैंडम वेरिएबल x is said to have Bernoulli distribution if it can take only two values. It can take only two values and that values will be either 0 or 1 and its PMF is given by probability mass function. Discrete के केस में probability mass function and in case of continuous distributions it will be probability density function. PMF is given by probability of x is equal to p की power x 1 minus p की power 1 minus x, because x can take only two values, either 0 or 1, where x is either 0 or 1 and 0 else cases. This is your probability where p is the parameter, p parameter है and it lies between 0 to 1. Also p plus q is equal to 1. This implies 1 minus p is equal to q. Okay, so this type of experiment is considered when there are only two possibilities, either that outcome will be of success or either that will be of failure. If that success comes out, ठीक है, success event comes out, so in that case that probability will be p, and if the failure event comes out, so in that case the probability of that event will be q, and p plus q, sum of all probability is equal to 1. So here either event will be success or it will be failure, so both p plus q is equal to 1. Okay, now in this case Bernoulli distribution, your mean and variance, here the random variable x is taking only two values, 0 and 1. If I take these values up to n, like from 0 to n, so in that case Bernoulli distribution will become binomial distribution. Okay, जब outcomes आपके जो possibilities हैं for x, that will be from 0 to n, and if that n goes to infinity, तो binomial will tend to normal distribution. वो भी we will discuss that later on. Right now कि Bernoulli will be binomial if this x is varying from 0 to n. Okay, now mean and variance in this case, it will be mu1 dash expectation of x I can open as summation x into px. This is the formula, and x is from 0 to 1, right? When x is 0, 0 into p of 0, 0 plus 1 into p of 1. Now put here x is equal to 1. If I put x is equal to 1, so it will be, first term will be 0, 1 into p, 1 minus p की 0 which will be p. तो mean क्या आया? p. Okay, now variance. For variance we need to calculate mu2 dash firstly, x square px, x from 0 to 1. Again x is either 0 or 1, 1 का square is again 1, so directly I can write it will be p. So now variance mu2 will be mu2 dash minus mu1 dash का square. p minus p square. I can take p common, 1 minus p will be q. So mu2 is equal to p q. Done. By directly the mean and variance method, I calculated the variance and mean. Now by MGF method, movement generating method, mean and variance. इस method में what will be your mean and what will be your variance, we will find out that. तो mxt is equal to summation e की power x from 0 to 1 tx p of x. Open this summation. It will be e की power 0, 1 and p 0 plus e की power t p of 1. Now p of 0 will be x की जगह 0 when you put 1 minus p की power 1 plus e की t. अब x is equal to 1 तो p की power 1, this will be 0 p. It will be 1 minus p which will be q plus e की power t p. Okay, this is your mxt function. Now to find out the mean and variance. Mean mu1 dash, वो क्या होगा, d by dt of mxt at t is equal to 0. It will be p. Done. Similarly mu2 dash, you will find out p and then mu2 will be mu2 dash minus mu1 dash square which is p q. Done. Now by third is CGF method. CGF method. Now CGF method में kxt is equal to log of mxt. What is your mxt function? Your mxt function is q plus e की t p. So in the same way like we did the definition of these cumulant, K1 will be your mean and K2 cumulant will be your variance. Just open this expansion log of, add 1 and subtract 1 and then open this expansion and then compare the coefficient of t. You will get your mean. Compare the coefficient of t square by 2, you will get your variance. Okay, this is by mean and variance method, this is by MGF method and this is by CGF method.